Hi, today we're going to talk about polyatomic ions. So, what are they? Polyatomic ions are ions, or atoms that gain charges by gaining or losing electrons. They have multiple atoms that stick together as a single unit. These are the 21 polyatomic ions. They are categorized into anions with negative charges and cations with positive charges. Typically, I like to view them by charges, and I like to look at the +1 and -3 charges first, as they have the fewest polyatomic ions, and they sort of seem to be the most awkward. So, one thing that... So you have the ammonium, which is the only one with a positive charge. And then you have the -3 charges, which are the phosphate and phosphite. Looking at this, you might notice the ites and eights, and every time the 8 will be the one with a larger value of oxygen atoms. This goes along for every one of them with 8 or 8. The charges aren't affected, but the amount of oxygen atoms is. So, note that carbonate, chromate, dichromate, and acetate, as well as those ions that have hydrogen, don't have ites at the end. But I'll talk about that in a bit. A trick to notice is that any time that you have a hydrogen, the charge is increased by 1. You can see this when phosphate adds a hydrogen and turns to hydrogen phosphate. The charge turns to -2. Same thing happens when it's dihydrogen phosphate. You get 2 hydrogen atoms and turns into a -1 charge. And this happens also with hydrogen sulfate. It goes from -2 to -1. It happens with carbonate, which then goes to negative. So then, the 3 with different charges leave us with 18 left to remember. Then the 4 ions with extra hydrogens mean that we have 14 to remember. So the other thing that you can do to remember them more easily is to simply remember all of the 8 ite ones, like I said before. You've got chlorate, chlorite, nitrate, nitrite, sulfate, sulfite, and that's it. So, with that, you've already conquered the further 6. You do have to definitely remember, though, that chlorate and nitrate, along with chlorate and nitrate, are 3,2, whereas sulfate and sulfite, and now I should remember that also, yeah, phosphate and phosphite are 3,4. So that's a good thing to remember. Also, definitely remember their charge. You only, of the ones with 8 ite, only sulfate is -2, and chlorate and chlorite and nitrate and nitrite, they're -1. So that's not that bad to remember. Also, you can remember some of the more unique ones, such as carbonate. It doesn't have an ite, but that makes it easy to remember. Then you have chromate and dichromate. Dichromate is easy, 2 chromates, but what at least I found it's sort of hard to remember is that it's 7 oxygen atoms as compared to 4, in addition of 3 oxygen atoms. So that leaves us with a few more. Hydroxide, I remember by it being oxygen, which has a charge of -2, and then hydrogen, which has a +1 charge. So then we have hydroxide with a -1 charge. And then you have acetate. That one's a bit confusing, but still. 2 carbons, 3 hydrogens, and 2 oxygens with a -1 charge. So really overall, actually I forgot to cover 2 more. You have cyanide, which is carbon and nitrogen with a -1 charge, and permanganate, which is magnesium and then 4 atoms of oxygen, and that is to the -1 charge. So while this remains a pretty big list, using some of these tips as long as asking others can really make it a lot easier. So, when we name compounds, we treat the polyatomic ion just like a regular ion. Look at here. We have beryllium sulfate. Beryllium sulfate. So you wouldn't do anything besides write beryllium sulfate 8. So here with bismuth 3 peroxide, to write the formula, we once again put in our bismuth, and that would be Bi, and we know that its charge is 3, and then we have peroxide. And what is peroxide? Peroxide is O2 with a charge of -2. So one thing to remember is whenever you're writing something with a polyatomic ion, if you just want to show multiples of that, then you put it in parentheses and you stick a subscript next to it. So for instance here, if we want to match up the charge to make it neutral, we would need 2 bismuth, and then put our peroxide in parentheses like this, and then we put in 3. And that is pretty much how you work with polyatomic ions. It's not that much different from working with an ion consisting of a single type of atom.